Okay, previously I showed that the IP address is hierarchical, right? As you know, many addressing schemes are hierarchical, right? For example, let's see, like the many addressing scheme. You know that it's many addressing scheme, right? You know that many addressing schemes are hierarchical, right? And like in my previous lecture, I used the building, right? I used the example, right? Building as an example. Let's say we have this building is what? The name of this building is Jack Brown Building, and we know that there's many rooms, right? Classrooms and many office rooms, right? And if to locate this room, right, we use Jack Brown Building, right? If this is room 124, then you use room 124, or like simply like Jack Brown Building 124. Well, let's say to locate this room, I'll say Jack Brown Building, right? And then a room, let's say this is the 545, right? Room 545, so I'll say room 545, right? And then maybe another example is a phone number, right? Also the phone number, the phone number is also hierarchical, right? Because let's say 48, right? And then you have some number, right? So this area code first, and then you have actual number, right? So for example, this is area code, right? And actual phone number. IP address, right, is hierarchical because what we have network portions, right? And then we have host portions. So this is like a building name, Jack Brown Building, and then room number, right? And then we have area code, right? And some telephone number, right? Let's say 5, whatever. So as you can see, many addressing schemes are hierarchical, right? So I like to show you, right? I like to show you one example. Let's just talk about this example. So typically, right? In your homework assignment or the exam, right? I give you something called a network address, and then I give you subnet mask, right? And then I'm going to ask you to find network address, and then I'm going to ask you to find broadcast address, and then the first host IP address, and etc. Right? So before we talk about this example, first let me just define what the network address really means, right? So let's just look at this example. So let me just use the animation mode, slideshow. Let's say from the current slide, okay. Okay, so basically the network address, as you can see, it's basically the address by which we refer to this network. So this is the network address to use to represent this network, the whole thing, right? And the broadcast address is a special address used to send the data to all hosts in the network. So if you use the broadcast address as a destination address, then if this guy wants to send a message to everyone, this guy can use broadcast address. right? So that everyone receive a packet or the message sent by, like, let's say for example in this node. And host address is the address assigned to the individual device, to the end device in the network. So in this case is 10.0.0.1. So this is like host address. So we know that we have three different kinds of address, right? And let's see. So example, when I give you this example, I typically give you the network address, and then I give you the subnet mask, because network address alone or the IP address alone does not really tell you much about the network. So typically I use the I give you network address and subnet mask, right? So in this example, right? So let's first talk about this example. Okay. The example is network address is what? 192, right? So the network address is 192.168.1.0, right? And then subnet mask is given is what? 255.255.255.0, right? And then okay, so the subnet mask is given, right? Is what? 255.255.255.0, right? So basically, if we convert this 192.168.1.0, right, to the binary format, you have this bits, right? So 110000, it's 192, and then 1010100, it's 116, etc. And the bottom, right, it shows the subnet mask 255.255.255.0, right? Or another way of write this subnet mask is what? We can use a prefix length notation, which is /24, meaning that we have a 24 consecutive ones, right? So this subnet mask, right, it really tells you where I can draw this boundary line. And I said once we draw the line where the one ends, right, where the one ends, so I draw the line right after this one. I know that this is what? This is a network portions, and this is what? Host portion, right? So oops. Okay, so when the subnet mask, right? Subnet mask has forms like a 255.255.255.0, right? That means this is the ones at the end of the third octet, right? It nicely ends at third octet. So basically, this is like, 1 1 1 1 and like 8 ones, right? Dot 1 1 1 1, then 8 of them. Dot 1 1 1 1 1 1 1 1, right? So 8 of them. And so we can nicely, right, because this is ends right at this dot, right? So we can nicely draw the line. If the subnet mask is like it's right, like either 255.255.255.0 or 255.255.00 or 255.0.0.0, right? If the subnet mask looks like this, then we don't really have to convert the decimal number to the binary, because this means that ones really ends at the, in this case, third octet, right? and this is like the ones at 1111, right? Ones at the end of the second octet, and in this case the ones at the end of the first octet, right? So we don't have to really convert decimal to the binary. We can simply draw the line, right? And we know the left portions, right? Left portion is the network address, and the right portion is the host portions, right? And the left side is network portions. Okay, so then there are three questions typically I'm going to ask you. First is what? First is find the network address, right? And then second question that I'm going to ask is to come up with what? Find the broadcast address. And then third question is, let's say, the address of the end device, like host address actually. Okay, so when I draw this line, we know that this network portion is 192.168.1, right? So first, to find the network address, I'm going to write the network portions. For the network portion, I'm going to use the red, which is this part, right? And then the host portion, I'm going to use the blue, which is this part, right? When the subnet mask is given like this, for example, right? So I'm going to write the network portions, which is I'm going to use the red. So 192.168.1, right? Dot. And then for the network address, the host portion, you always put 0. Okay, so that's your network address. So let me just draw the IP address space in this case. So if you use the previous analogy, right, this network address portion is like, for us is this one is what? Jack Brown building, right? Or the area code. So the next address after the network, the next one after network address is what? We have 192.168.1 right? The next one is basically 1, right? So 0 plus 1 is 1. And then the next address is 192.168.1 next is a 2, right? And then, so we can just keep going, right? So the next one is 192.168.1 dot what? 1.3, right? So we can just keep going until what? Let's just keep until we have 192.168.1 dot what? 254, right? And then the very next one is the last one, 192.168.1 dot what? 255, right? And we cannot go further because 255 is maximum, right? So when I just drew this IP address space, right? Let me just write through the box, right? And then, so I'm going to draw the line here, this boundary line. We know that this left side, right? This left side is network portions, right? And you know that this right side is what? Host portions. Okay, so if I just draw the diagram, right? This, you know, this network portion, if you use the same analogy, right? This is like a Jack Brown building, And this is like a room number 1, room number 2, and room number 3, room number 254, right, etc. So when I use the previous diagram that are in our lecture slide, let's just use this example. So basically, I'm going to draw the local area network. So let's say this cloud, right? Let's say this cloud is a local area network, this cloud, right? And in this, so this is LAN, local area network. And then we have a switch, right? We have a switch. And switch has a port, right? I mean, it has many ports, right? And then we have end device, right? So we have end device, and then we have many more, right? So first, network address, right? The network address refers to used to represent the local area network. So in our case, the network address is what? This network address is 192.168.1.0, right? So this network address to represent the whole thing, this cloud, this local area network, basically. It's not any particular individual device. It's basically, it's represent the whole cloud, this whole local area network. So basically this network address, right, is the very first IP address, and this IP address is represent the network, the local area network, basically. That's the main idea, right? And the very next one is which is 192.168.1.1, right? This 192.168.1.1. This one we used as we can use as for the end device. So the IP address is what? 192.168.1.1, right? We can assign this IP address to this first end device, right? So this end device can have IP address of 192.168.1.1, right? And the next one, right? The next one, 192.168.1.2, right? We can assign this IP address to what? The next end device. So I'm going to assign this IP address to the next end device. Let's say this could be your PC, right? Your workstations. So this guy can have IP address of what? 192.168.1.2 and etc., right? As you can see, right? The third one, obviously, this one will have what? 192.168.1.3, right? And then etc. So what is really common, if you look at this, individual IP address, like this, if you look at this host IP addresses, right? It has one thing in common, the network portion, right? This is common, right? So 192.168.1, right? This is common. So like this is what? If you use analogy, this is what? Jack Brown building, room number 1. Jack Brown building, room number 2. Jack Brown building, room number 3, and etc., right? So in this scheme, we can have what? How many rooms we can have? How many IP addresses for the host? So starting from the 1, and you know that this network address is reserved to represent this entire cloud, this entire local area network, right? So we cannot really use the network address for the host, or the workstation. So actually one we can use for the host, all the workstations or the end devices, we can starting from this line. So we have room number 1, room number 2. I'm going to use so room number 1, room number 2, room number 3, and all the way to what? Room number 254, right? And you know that this last one, by the way, this last one is reserved for the what? Broadcast address. Okay, so as you can see, if you look at this address space, the very first one is reserved for the network address, and the very last one is reserved for the broadcast address. And all the addresses in the middle, right, is reserved for the what? Host. Host addresses, or the addresses for the end devices. Right? So, yes. So, for example, like for the broadcast address, right? If this guy, the very first, device wants to send a message to everyone in this local area network. So let's say every device in this local area network, right? There are a couple of ways. Obviously, the first way is to send the let's say 253 messages, right? You can create 253 messages and send that message to each individual end device, right? Which is very inefficient. So for example, he can create the packets, right? And in the IP header, right, here's IP header. We know that in IP header there's a source address and destination IP address, right? So if the first guy wants to send a message to this guy, he can, the destination IP address, right? He can use 192.168.1.2. And then he create another message, right? And then for the source and destination IP address, right? For the destination, he can use this one, and etc. Right? So he can create, since there could be 254 host IP addresses, so except his own, right? He need to create 253 different messages, like 1 and then 2, the second message, and all the way to 253 messages, which is very inefficient. But another solution, right? Another neat solution is this host, right? This host is going to create the packet, right? And in the IP header, right? For the source address, he can use his own IP address, right? 192.168.1.1, right? For the source, because like this is like a from, right? And for the destination IP address, what he can do is he use the broadcast address, which is 192.168.1.255, right? Then just create one IP packets, right? It send this and to, let's say, to you just create only one message instead of creating one. Instead of creating 253 messages, you only create one IP packet with this destination IP address, which is broadcast address, right? He's able to send the same message. Let's say message is "I love you all," right? You can send this message to everyone just by creating one single packet with a broadcast address, right? So this is very efficient, and this is why we need to have a broadcast address. But anyway, the important thing here is that, as you can see, there are 3 different kinds of IP address, right? There are network address, and then we have broadcast address, and then we have what? Host address. So we have 3 different kinds of address. The very first one is reserved for the network address, which represent this local area network. And then we know that we have a broadcast address. I just explained why we need the broadcast address. And then as you can see, the subnet mask plays a very important role, right? Because it really tells you which portion is network portions and which portion is what? Host portion, right? So in that sense, we know that IP address is hierarchical, right? So like this portion here is Jack Brown building or the area code, and this portion is room number and actual phone number, right? So this is good analogy. So in the next lecture, right, I'm going to show you one more example. Example number 2, right? So let me just first stop here.